So good afternoon. Welcome to second week grade class, Prerana. Last week I discussed about the rainfall, how to measure the rainfall, how to present the rainfall data, how to find out the missing rainfall data, frequency analysis. These are all discussed in our last topic. So this also one of the important. The three important phases in hydrological cycle is evaporation, then precipitation, runoff. So these three phases, runoff is our important thing. So which we will discuss now actually. So let's see the important which will usually asked in the gate examinations is about hydrographs. So without hydrographs, there's a question of gate in every year, in any year. So what is hydrograph? Hydrograph is it's a relation between the discharge versus time. That is straight away. One more question. But in depth, hydrograph is a response of a given catchment to a rainfall input. So it consists of flow in all three phases of runoff. So all three phases in runoff is surface runoff, subsurface runoffs, base flow. So the surface and subsurface runoff together called as direct runoff. So base flow is separated from the surface and subsurface runoff. If you separate the base flow, you are supposed to get direct runoff. That's So first of all, we discuss about flood hydrograph. So flood hydrograph includes surface runoff, subsurface runoff, base flow. That's all. Here we see this diagram. If we separate the base flow from the total hydrograph or flood hydrograph simply, so we are supposed to get direct runoff hydrograph. So there is a hydrograph shown in the figure. So it also called storm hydrograph. So storm hydrograph, flood hydrograph, or total hydrograph, or simple hydrograph. That's all. So this hydrograph consists of surface, subsurface, base flow. So total runoff hydrograph. See, storm hydrograph, total runoff hydrograph, flood hydrograph, or simple hydrograph. So any terminology that means the runoff includes surface, subsurface, and base flow. If we separate the base flow from this, we are supposed to get direct runoff. So it's also called storm hydrograph or total runoff hydrograph. So flood hydrograph obtained by plotting graph between stream flow variation versus time. Flood hydrograph consists both direct runoff as well as base flow. So flood hydrograph consists of direct runoff as well as base flow. What is direct runoff? Surface runoff and subsurface runoff. So if we see this is a simple diagram. So duration D hour, let us say this is a rainfall quantity or amount of rainfall. If you draw the discharge versus time, so let's say point A, point B, right? Point P peak, point C, D, N. So if you observe this component, if you observe clearly, MA equal to base flow recession. So base flow recession is called MA. AB is a rising limb because of its rising. So it's all if you see the runoff, for example. So the rainfall occurred in our college, let us say for 2 hours continuously, 10 centimeters rainfall. So sometimes what we observed is the rainwater coming from the upstairs or roof, it will flow, right? So initially like this, but afterwards you can reach this point, right? The rising limb, then the CD is falling limb because of once the runoff is reduced, the graph is like this, that is falling limb. So DN, this one. So base flow recession, that is point B and C are inflection points. That's point B and point C as inflection points. That's it is an important diagram. If you know this diagram, it's very, very easy to solve the problems also. So P is the peak, right? So this is the indication, peak flood, right? Then direct runoff hydrograph, DRH. So already I told you that if you separate, you detect the base flow from the total hydrograph, you can get direct runoff hydrograph. So the hydrograph obtained after separation of base flow is called direct runoff hydrograph, right? The hydrograph which can be obtained after the separation of base flow is called direct runoff hydrograph. Or if you separate the base flow from the total hydrograph, it may be called as direct runoff. So DRH. So it is obtained by separation of base flow from the flood hydrograph. It's also called as surface runoff hydrograph. So the formula for finding falling limb endpoint or base flow separation, where n equal to 0.83 a power 0.02, where n equal to time interval in days. For example, the the flow is continuous for 20 days. So what is time interval? N equal to 20. A equal to drainage area in square kilometer. So then only its form is applicable. N equal to 0.83 A power 0.2. So the area under the direct runoff hydrograph represents the runoff volume. So the depth of runoff equal to volume of runoff by area of catchment. So volume by V. So volume in cubic meter, area of catchment is square kilometer. You can get meters, that will multiply by 100. You are supposed to get depth of runoff in centimeter. So you see volume of runoff equal like this. First ordinate plus temperature formula A plus B by H like this. So area of direct runoff hydrograph. This is the formula which can be applied.
సార్ సార్
Ah,
కొద్దిగా స్లోగా చెప్పండి సార్.
right. Okay. Okay. Due to the time restriction, okay, that will go slowly. See, let us see. So this is a hydrograph. So it is a discharge versus time. So discharge Q, time T. So how to get discharge? How to get time T actually? So I already told example now. So for example, the rainfall occurred, which is raining in your college for example 2 to 3 hours. So just after some time, if you observe the quantity of water coming out and flow. So initially, the discharge is slowly. Then afterwards, that's increasingly. At one point, it reached at point P peak. After some time, so for example, the rain is slowed down. So still runoff is continue. So after some time, if you observe, the discharge will be reduced. So that's why that will be indicated in this figure. So if you see this hydrograph is total hydrograph. Total hydrograph means whatever the flow obtained from the upstairs that you drawn like this. But after base flow means after percolation to the groundwater, because there is the water is absorbed in the ground. You know that after absorbing ground, that it will flow surface. So if you deduct or if you separate base flow from the total hydrograph or total runoff hydrograph or simple hydrograph, you are supposed to get direct runoff. See, indicated in this figure also. This is a base flow. This is a total hydrograph. If you separate this hydrograph is obtained is called direct runoff hydrograph. That is indicated in the here. So depth of runoff, how to get the depth of runoff actually? If you know the total volume, if you know the area, the volume divided by area, which will give depth of runoff. So that depth of runoff equal to volume of runoff by area of catchment. So volume of runoff means area into rainfall depth. If you divide that area, volume by area, you can get depth of runoff in meters. Multiply by 100, it will be in centimeters, like this. So the trapezoidal rule. So you know the area of trapezoidal half H and A plus B, like that. Volume of runoff equal to area of direct runoff hydrograph. So that what is the area of direct runoff hydrograph? So of BH. What is B? Delta T, right? What is B and H? Two ordinates. So first ordinate plus last ordinate divided by 2 plus some of the remaining ordinates, which will give the volume of runoff. So where delta T equal to time interval. For example, what is meant time interval actually? If you observe 1 hour interval, 1 hour, 2 hours, 2 hours, like that. The delta time is time interval only, not full time, only time interval. 1 hour, 2 hour, 3 hour, like this. So now there is a very, very important effective rainfall. So you see, if you observe simply rainfall, that means rainfall recorded in the particular area 2 centimeters. That's called simply rainfall. That's all. Next, normal rainfall. Normal rainfall of Tirupati. This means 30 years of the average. So for example, 1970 to 2000, 30 years. So 30 years of average means for each year 1970 100 mm, 1971 200 mm, 1972 300 mm, like this for a number of years. How many number of years?
సార్ ఈ పీడిఎఫ్ మాకు పెడతారా సార్?
తప్పకుండా
లాస్ట్ క్లాస్ ఎవరికి పెట్టారు సార్?
లేదా ఇక నేను షేర్ చేస్తాను.
ఓకే సార్. ఓకే సార్.
ఓకే, జస్ట్ ఐ విల్ మోడిఫై ఇట్, ఐ విల్ ఆల్టరేట్ అండ్ టు సూట్ యువర్ రిక్వైర్మెంట్స్. మీకు పనికి వచ్చే విధంగా తయారు చేసి పంపిస్తాను.
ఓకే సార్, థ్యాంక్ యూ సార్.
మీకు ఏ విధంగా అయితే దాన్ని యూజ్ అవుతుందో, నీట్గా అవుతుందో అది కట్ చేసి ఎడిట్ చేసి పంపిస్తాను.
ఓకే సార్, థ్యాంక్ యూ.
రైట్. సో this is a very, very important actually. Effective rainfall. So rainfall normal rainfall, average rainfall, effective rainfall. So all are rainfall only. So simply you please remember that rainfall means measurement. By measurement only you are supposed to know about the how much rain in the particular area. Normal rainfall, it is calculated, it's not measured because of already measured, recorded, then take an average of 30 years. That we will be supposed to arrive at the normal rainfall of Tirupati city or Rayalaseema, Andhra, Telangana, like that. So in particular area, normal rainfall means Tirupati annual rainfall is like this. So that's the normal rainfall. Then average rainfall, again it's calculated. So for example, January month, 100 mm, February month, 200 mm, March, 100. Like that. If you divide by 12, you are supposed to arrive the average, yearly average, like that. So rainfall, normal rainfall, average rainfall, effective rainfall. What is effective rainfall? So the effective rainfall defined as that rainfall is neither retained on the land surface nor infiltrated into the soil. So effective rainfall is the part of the rainfall that becomes direct runoff at the outlets of the watershed. So direct runoff refers to the option A, normal rainfall, B, average rainfall, C, effective rainfall, D, none of the above. So the answer is effective rainfall. So direct runoff always refers to effective rainfall. Why? Because of, so effective rainfall is simply directly told that total rainfall minus losses, whatever the losses may be. So after deducting losses, the rainfall obtained is effective rainfall. Then unit hydrograph. So unit hydrograph is defined as the hydrograph of direct runoff. Very, very important. Again, what is direct runoff? So if you separate base flow from the total runoff, it's called direct runoff. Now, unit hydrograph is defined as the hydrograph of direct runoff resulting from 1 unit depth because of 1 centimeter effective rainfall. 1 unit depth of rainfall excess. Here, rainfall excess means effective rainfall. Again, occurring uniformly over the basin and at a uniform rate for a specific duration. So this is called D-hour unit hydrograph. This method was first suggested by Sherman. This is very, very important theory bit. So who is the unit hydrograph derived by L.K. Sherman. So if we draw the graph between a discharge versus time, so this is like this. So for example, the basic assumptions of unit hydrograph theory. So there are assumptions because of which the whatever the rainfall occurred in the field, whatever you studied, but it is different from the practical things. So before deriving unit hydrograph, you are supposed to make some assumptions. So what is called as, one is time invariance. So the direct runoff response to a given effective rainfall in a catchment is time invariant. Because of the time to time rainfall is different. So what is the simplest actually? So direct runoff hydrograph for a given effective rainfall in a catchment is always the same irrespective of when it occurs. Second one is a linear response. So the direct runoff response to the rainfall excess is assumed to be linear. So it means point, for example, x1, t and causes an output of y1, t. X1t means rainfall. Y1t means runoff, that's all, input and output. So and an input of x2t causes an output of y2t, like the and so on. So its total output is y1 of t plus y2 of t. So like so on, y3t, y34, like that. This is called linear response. So if you discuss about the applications of unit hydrograph, because of what is a unit hydrograph? Unit hydrograph is, it's a direct runoff hydrograph resulting from 1 centimeter effective rainfall specified in a unit duration. So what are the applications actually? What is the use of this hydrograph by drawing this? So by using unit hydrograph, one can easily calculate the direct runoff hydrograph. So if you draw the unit hydrograph, you are supposed to get a direct runoff hydrograph. So what is the use of direct runoff hydrograph actually? Direct runoff hydrograph gives direct runoff from how when it is separated from the base flow. If you separate the base flow, the runoff resulting from surface is called surface runoff. So then that is that quantity of water is supposed to store in your reservoir or any other system. So that's why the first application of unit hydrograph is easily calculate direct runoff hydrograph. Let it be assumed that a D-hour unit hydrograph and storm hydrograph are available. Right? The initial and infiltration losses are estimated and detected from the storm hydrograph to obtain effective rainfall hydrograph. Effective rainfall hydrograph is not hydrograph. ERH means effective rainfall hydrograph. What is meant by hydrograph actually? The graph showing the relation between rainfall intensity versus time. So the initial and infiltration losses means, so for example, the initial losses are there. So then it is detected from the storm hydrograph. So the effective rainfall hydrograph is then divided into M blocks of the DH duration each. The rainfall excess in each DH duration is then operated upon the unit hydrograph successively to get the various DRH curves, the direct hydrograph curves. So the ordinate of these direct run hydrographs are suitably logged to obtain the proper time sequence and are then collected and added at each time to obtain the required net direct run of hydrograph due to the storm. So of course, this is the, if you see the calculated problem, you are easily understand. But thing is, here only one basic point. The total hydrograph or total runoff hydrograph, simple hydrograph includes surface runoff, subsurface runoff, base flow. If you separate the base flow, you are supposed to get surface and subsurface together called as direct runoff. This is important. So when you come to the unit hydrograph, it's a unit hydrograph is nothing but direct runoff hydrograph that but result from the 1 centimeter effective rainfall. For example, the resultant hydrograph after separating the base flow is called direct runoff hydrograph. That direct runoff hydrograph refers to, for example, 10 centimeter effective rainfall. If you are supposed to find out 1 centimeter effective rainfall, it may call as unit hydrograph. So the derivation of unit hydrograph by two methods. One is method of superposition. Second one is the S-curve technique. So already discussed in the 3.2 also. So method of superposition means if you know the one, for example, 2-hour duration, we are supposed to find out 4-hour duration of hydrograph. You can find out 6 hours. You can find out 8 hours, like that, multiples. But in S-curve technique, for a given hydrograph is 2 hours, we are supposed to find out the 3 hours unit hydrograph. The method of superposition may not apply. Then you may go for the S-curve technique. So if you see method of superposition, if a d-hour unit hydrograph is available and it is desired to develop a unit hydrograph on nd hours, where n is integer, for example, n is 1, 2, 3, 4 like this. It is easily accomplished by superimposing n unit hydrographs with each graph separated from previous only by dh. The combination of these curves gives n centimeter rainfall excess. By dividing with n, we get n into dh unit hydrograph. So this is a method of superposition. So of course, that method of superposition is we'll see later also. I will show you. Then S-curve technique. So in S-curve technique, if it is desired to develop a unit hydrograph of duration m into d, where m is a fraction, here n is an integer. See the difference between the method of superposition and S-curve. Here n is an integer, but here m is a fraction. So the method of superposition cannot be used. So this can be achieved by S-curve. So the S-curve, also known as S-hydrograph. S-hydrograph is a hydrograph. What's meant a hydrograph? So it's a direct runoff hydrograph resulting from 1 centimeter effective rainfall. So S-hydrograph is a hydrograph produced by continuous effective rainfall at a constant rate. So it's continuous effective rainfall. Please note that the difference between the method of superposition and S-curve technique. So produced by continuous effective rainfall at constant rate for an indefinite period. So it's a curve obtained by a summation of an infinite series of DH unit hydrograph. DH means D hours spaced, 2 hours, 3 hours like that. Spaced D hours apart at any given time, the ordinates of the various curves occurring at that time, coordinates are summed up to obtain ordinates of S-curve. This S-curve is due to D hour unit hydrograph. It has initially steep portion and reaches a maximum equilibrium discharge at a time equal to the time base of the first unit hydrograph. So the average intensity of effective rainfall produced in the S-curve is 1 by d centimeter per hour, and equilibrium discharge Q, this is important formula, equilibrium discharge Qs equal to A by d into 10 power 4 directly gives meter per hour. But area is in square kilometer only. So if A in square kilometer only, this formula is applicable. D is also duration in hours of effective rainfall at the unit hydrograph. Say if A is in kilometer square, D is in hours, right? As it is in 10 power 4, the equilibrium discharge is obtained in meter cube per hour. So let us say derivation of T hour unit hydrograph. So what is T hour means? When T may be 1 hour, 2 hour, 3 hour like that. So consider the two direct runoff hydrograph S-curves A and B, as for example. Displays by T hours because of 2 hours shifted to 1 hour like this. So if the coordinates of B are separated from that A, the resulting curve is a direct runoff hydrograph produced by a rainfall excess of duration T hour. So and magnitude also 1 by T into T. So for example, D hours 1 by T into T. What is it actually? You are supposed to obtain T hour unit data graph. Now, hence, if the ordinate differences of A and B is SA minus SB, this SA minus SB are divided by T by D, SA minus SB by T by D. The resulting coordinates denote a hydrograph due to an effective rainfall of 1 centimeter and of duration T hours. That is a T hour unit data graph. Now, if you see the limitations of unit data graph, this is important actually. So, one more questions. So, unit data graph theory is applicable for a catchment area is less than 5,000 square kilometer. So, unit data graph theory is applicable for catchment area is less than 5,000 kilometers, means it's a maximum limit. So, what is the maximum limit of unit data graph? Option A, 5 kilometers, B, 50 kilometers, C, 5,000 kilometers, like this. Very important question. Previously, it's asked many times. So, unit telegraph theory is applicable for catchment area is less than 5,000 square kilometer. Then, unit telegraph theory fails if any storage facility in the catchment, that is lake, pond, etc., within the catchment. Then, unit telegraph assumes uniform distribution of rainfall over the catchment and constant intensity for the duration of rainfall excess. So, in practice, these two conditions are never strictly satisfied. Now, synthetic unit data graph. Just you know about synthetic unit data graph. The problems never asked in synthetic hydrograph in GATE also. But what is synthetic hydrograph means? So, for example, how to get unit data graph actually? So, unit data graph is supposed to calculate, you know, the discharge because of runoff data, you know the time. Then we are supposed to find draw a unit data graph. But in remote locations means, for example, where the data is not available. So if you want to draw the unit data graph on that area, you are supposed to use synthetic unit data graph. That is mentioned. Let's say synthetic unit data graph is a unit data graph generated by using empirical formula without making any physical measurement. Right? So, for example, any data is not available. So, Cinder, which is a scientist, has proposed a set of empirical equations to generate the components of unit data graph. So, first of all, here is synthetic unit data graph. Right? Synthetic unit data graph is a for what actually not physical measurement. It is due to empirical formula. That's important. That's all. Of course, it may not never asked in the GATE examination also. No need to bother about that. So now instantaneous unit data graph. So what is instantaneous means? You are supposed to find out unit data graph inside itself. For example, the limiting case of unit data graph of zero duration is known as instantaneous unit data graph. Say the following hydrograph is having zero duration, or the following hydrograph is applicable for zero duration. A, unit data graph. B, synthetic unit data graph. C, instantaneous unit data graph. D, none of the above. So zero duration is meant for instantaneous unit data graph. So IUH, thus instantaneous unit data graph is a fictitious conceptual unit data graph which represents the surface runoff from the catchment due to an instantaneous precipitation of the rainfall excess volume of 1 centimeter. Of course, it may not important, but only thing is the zero duration is very, very important in the case of instantaneous unit data graph. But a get point of. Let's say this question. So the ordinates of a 3-hour unit data graph. So for just please listen theory questions, but you can practice practicals also. Practice more number of questions. See, read the problem, understand. The ordinates of a 3-hour unit data graph means the unit data graph is a 3-hour unit data graph because of that effective rainfall is 3 hours duration. So ordinate means measured at 1 hour interval. So each 1 hour you are taking discharge levels. So that's why it's mentioned here. So the ordinates of a 3-hour unit data graph at 1 hour intervals starting from time t equal to 0 or so 0, 1, 2 like that. 0 or 0 meter per second, 3 meter per second, 8, 6, 3, 2 and 0 meter per second. right? So use Trapezoidal rule for numerical integration if required. A storm of 6.6 centimeter occurs uniformly over the catchment in 3 hours. So anyhow, unit data means that during unit radiograph preparation, a storm is occurred, 6.6 centimeters occurs uniformly over the catchment in 3 hours. If pi index is equal to 2 millimeter per hour and base flow is 5 meter per second, what is the peak flow due to the storm? Say, for example, just to understand the problem first. Of course, calculation part may not important. So these are the alternates. One, right? Pi index is equal to 2 millimeter per hour. What is pi index actually? Pi index at an index above which rainfall volume equal to runoff volume. So the above pi index value may be considered as runoff. What is it? 2 millimeter per hour actually? 2 millimeter per hour is pi index. Above that, rainfall volume will runoff volume. What is base flow? 5 meter per second. What is the purpose of to given a base flow here actually? Hydrograph means surface runoff, subsurface runoff, base flow. If you separate the base flow, you are supposed to get direct runoff hydrograph. Now here, what is the peak flow due to the storm? So let us say, solution also please listen. Maximum ordinate of unit hydrograph. How much? 8 meter per second. So what is the effective rainfall in 3 hours actually? 6.6 centimeters occurs. It is total rainfall minus 0.2 millimeter per hour is the pi index. For how many hours? 3 hours. So 0.2 into 3, right? How much actually? 6 mm. So 6.6 centimeters minus, which will get 6 centimeter. Then peak flow due to storm hydrograph. SH means storm hydrograph. What is storm hydrograph actually? Total hydrograph. So this, see, this 8 meter per second the peak discharge, 6 hours, right? 6 means here effective rainfall. Plus 5 means base flow. It includes base flow because of the total run of hydrograph includes surface, subsurface, then base flow. So this means effective rainfall plus base flow, which will gives total hydrograph. Means that is peak flow of storm hydrograph. Let's say this question. A 9-hour unit hydrograph, because of unit hydrograph developed due to effective rainfall of 9 hours. If a catchment is triangular in shape, so with a total time base of 36 hours and a peak discharge of 18 meter per second. So try to draw the triangle itself. So triangle base is 36 hours. So if you draw the triangle, you know that the peak discharge means highest point. That means 18 meter per second. The area of the catchment in square kilometer is this one. Say whenever the term unit hydrograph refers to what? It is a hydrograph. It is a direct runoff hydrograph resulting from 1 centimeter effective rainfall, right? So here the area of catchment is A. There's an area and catchment in square kilometer into 10 power 6. That's called in terms of meter square. If you multiply 10 power 6, it will give meter square into 1 by 100 means effective rainfall 1 centimeter. That divided by 100 is meters. That's equal to area of the triangle means half BH of base is 36 into H is 18 meter per second. So 18 meter per second into 60 per minute into 60 per hour. Like this will arrive. So if you can find out the A from this 117 square kilometer. So the average rainfall for a 3-hour duration storm is 2.7 centimeter and the loss rate is 0.3 centimeter per hour. Let us say, understand the problem first. The average rainfall for a 3-hour duration storm is 2.7 centimeter. That's the rainfall. And the loss rate is 0.3 centimeter per hour. So 0.3 centimeter per hour into 3 hours means 0.9 occurs. Now 2.7 minus 0.9 like this, right? The flood hydrograph has a base flow of 20 meter per second. What is flood hydrograph? It's a total hydrograph again. So it has a base flow of 20 meter per second. Now if you separate the base flow from the flood hydrograph, you can get direct runoff hydrograph and produces a peak flow of 210 meter per second. The peak of a 3-hour unit hydrograph is, let's say step by step you see. So first of all, rainfall within 3 hours, 2.7 centimeter. So loss rate is given 0.3 centimeter per hour. Like that, what is the total loss in 3 hours? 0.3 into 9, 0.9 centimeters. Now, what is the rainfall excess means? Rainfall depth minus total loss You get 1.8 centimeter in 3 hours. Now, flood hydrograph peak flow, how much actually? 210 meter per second. This is flood hydrograph. Flood hydrograph includes surface, subsurface, base flow. Then base flow is given clearly. Now, if you separate base flow means 210 minus 20, you can get 190 meter per second. So this 190 meter per second is what actually direct runoff hydrograph. But direct runoff hydrograph for effective rainfall of 1.8 centimeter, right? What is unit hydrograph again? For 1 centimeter effective rainfall. So the peak due to 1 centimeter means for 1.8 centimeter, 190 meter per second. For 1 centimeter, 190 by 1.8, 105.6 meter per second. It is a ordinate of unit hydrograph. That is a unit hydrograph. Understand? Next. Then if you see a 4-hour unit graph of a catchment is triangular in shape. Again, similar problem. So if we draw the triangle, so base of 80 hours, the area of the catchment is 710 square kilometer. The base flow and pi index are 30 meter per second and 1 millimeter per hour respectively. A storm of a 4 centimeter occur uniformly in 4 hours over the catchment. The peak flood discharge due to storm is see, read the problem first. A 4-hour unit hydrograph means the hydrograph resulting from 4 centimeter effective rainfall of a catchment means one of the area draining into the flood. What is the shape actually? Triangular in shape. So what is the base of triangle? 80 hours. So mark it. The area of the catchment is 710 square kilometer. The area of the catchment is 710 square kilometer. So the base flow means 30 meter per second. That's the groundwater flow. Pi index means its losses 1 meter per hour. A storm of a 4 centimeter occurs uniformly in 4 hours over the catchment. Now find out the peak flood discharge due to the storm. See, for simple, depth due to storm, how much? 4 centimeter. What is the loss actually? 1 meter per hour. Like that into 4 hours, how much? 4 mm, it will give 0.4 centimeter. Now what is rainfall excess actually? Full total depth minus loss. That will give 3.6 centimeter. Now what is peak of flood actually? That 3.6, where you get actually 3.6 actually, let's see. So if you separate the base flow here, that will get, so, and also, see, with the triangular in shape, that's area of pH into A into 720 square meter means already area given, 720 square kilometers, 720 into 10 power 6 square meters into 1 by 100, right? If you get it, you are supposed to get this value. Plus 30 means base flow. What is base flow? 30 meter per second. So if you add the base flow, you can get total hydrograph like this. Now see this. So the peak flow of flood hydrograph caused by isolated storm was observed to be 100 meter per second. The storm had a duration of 8 hours and total depth of rainfall of 7 centimeter. The base flow and the pi index were estimated as 20 meter per second and 0.25 centimeter per hour respectively. If in the above storm, the total rainfall were 9.5 centimeter in the same duration of 8 hours, the flood peak would have been larger by. So this is a very, very typical problem. Typical problem is easily problem, but gate problem, this set of questions only asked in the gate. See, first of all, step by step we see effective rainfall. What is effective rainfall actually? Total rainfall minus losses. So how it is actually? So total depth is 7 centimeter. 7 minus 8 hours. So 0.25 centimeter per hour is the average loss for hour. This 0.25 centimeter per hour into 8 hours. This will give 5 centimeters. This is called effective rainfall. What is the peak flow actually? 100 meter per second. Base flow is how much? 20 meter per second. So if we deduct the total peak minus total discharge minus base flow, we are supposed to get direct runoff hydrograph or direct runoff. That is peak minus base flow is 100 minus 20, 80 meter per second. So peak of unit hydrograph, how to this actually, this is direct runoff hydrograph. Unit hydrograph is 1 centimeter effective rainfall. So this 80 meter per second is refers to 5 centimeter effective rainfall. For 1 centimeter, 80 by 15. So 60 meter per second. After this, I think understand. Now, we see 9.5, right? Means this one. So this 9.5 means if in above storm the total rainfall then 9.5 centimeter aithe, suppose if the total rainfall is 9.5 centimeter, then how much? That was asked in the previous case. So this is 9.85. Lots are same, 0.25 into 8, that will be 7 centimeter. Again, peak means same 140 meter per second. Now it is 40% more than the earlier. Now it is a simple two-step problem. A basin with an area of 756 square kilometer has 6-hour unit hydrograph, which could be approximated as a triangle with a base of 70 hours. The peak discharge of direct runoff hydrograph due to 5 centimeter rainfall excess in 6 hours from that basin is. So here's the problem actually once again. A basin with an area of 756 square kilometers and from due to 6 hours unit hydrograph, which could be approximated as a triangle, again triangle in shape. So the peak discharge of a direct runoff hydrograph due to 5 centimeter of rainfall excess in 6 hours from that catchment is. See, whenever the unit hydrograph means 1 centimeter effective rainfall. If we draw the triangle, right? Now area, how much area actually? 756 square kilometer into 10 power 6 meter square into 1 centimeter effective rainfall. That's 1 by 100. That's equal to area of the triangle. Area of triangle is half BH, half into B, 70 hours, H. How much H actually? Meter per second, H as it is. But what about 3600? If it is meter per second into 60 per minute into 60 per hour. So then you can suppose to get the peak equal to 60 meter per second. Now, what is DRH peak actually? Why 5 into 60 actually? This is a unit hydrograph coordinate 60 meter per second because I already mentioned 6 hours unit hydrograph. Unit hydrograph refers 1 centimeter effective rainfall. So now it is asking in 5 centimeter of rainfall excess. Now 5 into 60, it's got 300 meter per second, like this. The number of problems asking every get information, this type of only. So let's see, a 3-hour storm over a watershed had an average depth of 27 mm. Right? Read the problem carefully. A 3-hour storm over a watershed had an average depth of 27 mm. So the resulting flood hydrograph was found to have a peak flow of 200 meter per second and base flow of 20 meter per second. If the loss rate could be estimated as 0.3 centimeter per hour, a 3-hour unit hydrograph for this watershed will have a peak of. See, again, so what is the rainfall excess means? What is the effective rainfall? So 27 mm is the depth minus. What is the loss actually? 0.3 centimeter per hour. So 0.3 centimeter per hour. Like this, let us say 3 mm into 3 hours. It comes around 18 mm. So peak without both flow means it is 200 meter per second minus base flow, which will around 180 meter per second. Now, this 180 meter per second for what? 18 mm effective rainfall. For 1 centimeter, that's 100 meter per second. So 180 by 18, which comes 100 meter per second, like this. So we see the drainage area of watershed is 50 square kilometer. The pi index is 0.5 centimeter per hour and the base flow at the outlet is 10 meter per second. 1 hour unit hydrograph. 1 hour unit hydrograph means unit depth is 1 centimeter. Of the watershed is triangular in shape with a time base of 15 hours. The peak coordinate occurs at 5 hours. The peak coordinate of the unit hydrograph is. So once again, we draw the triangle. So area 50 square kilometer into 10 power 6 square meters into 1 centimeter effective rainfall means 1 by 100 meter. That's equal to half BH. Half into base is 15 hours into peak. Once again meter per second into 60 per minute into 60 per hour. That's it can be around as 18.5 meter per second. So this number of problems asking like this model only. See, easy understand it. That's right. Read the problem carefully. The total rainfall in a catchment of area 1000 square kilometer during a 6-hour storm is 90 centimeter. So the total rainfall is 90 centimeter. Area is 1000 square kilometer. from what up to from 6 hours storm. So the surface runoff due to this storm computed from a triangular direct runoff hydrograph is like this. So 1 into 10 power 8 cubic meter. Here 1 into 10 power 8 cubic meter. So the pi index for this storm in centimeter per hour up to 1 decimal place is a previous gate examination. See, read the problem. See, latest data. Catchment area is equal to 1000 square kilometers. That's equal to into 10 power 6 meter square. So rainfall, let us say P. How much? 90 centimeter. How much duration actually in 6 hours storm? So what is surface runoff? 1 into 10 power 8 cubic meter. Now what is runoff actually? That is total runoff divided by area. We are supposed to get runoff depth. Understand? So total runoff volume by runoff area. You can get meters. Like this here. 1 into 10 power 8 by 1000 square kilometer and 10 power 6. That's around 1 by 10 meters converted into 10 centimeters. Now what is pi index actually? Rainfall minus runoff for total duration. P minus Q by T. So what is meant by P? Total rainfall 90 centimeter minus what is the runoff depth 10 centimeter distributed in 6 hours. So it's come to 1 centimeter per hour is the right answer. This one. So this is called the previous gate problem. An effective rainfall of 2-hour duration produced a flood hydrograph peak of 200 meters per second. The flood hydrograph has a base flow of 20 meters per second. If the spatial average rainfall in the watershed for the duration of the storm is 2 centimeter and average loss rate is 0.4 centimeter per hour, the peak of 2-hour unit hydrograph in meter per second up to 1 decimal place is, see, simple direct runoff hydrograph peak. How much actually? This is a total hydrograph. If you separate direct from base flow means 20 meters per second, which will give direct runoff 180 meters per second. So whenever they see effective rainfall means direct runoff hydrograph, that's no doubt. 1 centimeter rainfall means that is refers to unit hydrograph. So 180 meters per second. So what is the effective rainfall actually? Total is here 2 for unit hydrograph centimeter of 1 decimal. 2-hour duration, right? The flood hydrograph by 20 meters per second. Watershed duration of storm is 2 centimeters. So this 2 centimeters minus what is the loss actually? 0.4 centimeter per hour. For 2 hours, like this, 2 into 0.4. So it's come to 1.2 centimeter. Now, 180 meters per second for 1.2 centimeter. For 1 centimeter, like this. For 2 hours unit hydrograph, 1.8 to 1.2. So that's 180 meters per second. So this problem is already discussed in T2 also. So this is time 2-hour unit hydrograph, right? 2 hour lagged by 2 hours. Therefore, this calculation may not important to get point of view also. Straight away see peak of flood equal to 92 plus base flow. What is base flow? 5 meters per second. What is the peak actually? 92. So 92 plus base flow, which will give flood hydrograph. That's all. That's calculation may not important to get point of view. So this simple problem. So the ordinates of a 2-hour unit hydrograph for a catchment are given as time interval ordinates. So ordinate meter per second of a 4-hour unit hydrograph for this catchment, the time of 3 hours would be. So straight away, so 25 plus 5 by 2. So average, that's 15. Let's see. So we stop here after discussing this problem. See, the direct runoff hydrograph in response of 5 centimeter rainfall excess in a catchment is shown figure. So the area of the catchment in hectares is, see, triangular in shape. Let's say discharge in meter per second, time in hours. Already I told you that triangular in shape means area is half BH. Whenever the term direct runoff hydrograph means effective rainfall. So response to 5 centimeter rainfall. This is called rainfall excess or effective rainfall. Now see catchment area A into 10 power 4 means square meter. If you multiply 10 power means in square meter, that's all. A into 10 power 4. A in hectares into multiple by 10 power 4 means square meter. Into 5 centimeter effective rainfall. 5 by 100 in meters. That will give this area of unit, this area of direct runoff hydrograph of 6B into H means this one. 1 meter per second into 60 into 60. That's all. So we are supposed to get to 21.6 hectares directly. Here, see, the ordinates have a 1 hour unit telegraph at 60-minute interval. So 1 hour, 60-minute interval. Like this, a 2 hour storm of 4 centimeter excess rainfall occurred in the basin from 10 a.m. Considering constant base flow of 20 meters per second, the flow of the river. So a simple problem actually. See, if you are adding base flow, you are supposed to get total flow. So here, see, 8 into 2 because of 2 hours unit telegraph plus 12 into 2 plus 20. Like this, around 60. See this problem. An isolated 3 hour rainfall event on a small catchment produces a hydrograph peak and the point of inflection on the falling limb of the hydrograph at 7 hours and 8.5 hours respectively after the start of the rainfall, assuming low losses and no base flow contribution. The time of concentration hours for this catchment approximately. So it's of course direct question actually 7 hours minus 1.5, it comes around 5.5 centimeter. Of course, the formula is also there, starting formula n equal to 0.87 a power 0.2. That will give straight away this answer actually. So of course today we shall stop here and I will continue in the next class also. So wait for some time. So after I stopped recording, let us see which mail it is supposed to go.